Hello everyone, my name is Andrew Manzi, Technical Marketing Manager at Autodesk, and welcome to this brief course on mobility simulation, Know the Basics. So I'm going to take you through the course content first. The course itself is aimed at people with no prior knowledge of mobility simulation or the considerations around people movement. The aim of the course really is to impart just enough information so that anyone could feel confident in firing up the software and creating a basic simulation. So the course is broken down into 5 modules. The first module, getting started, followed by pedestrian simulation, traffic simulation, multimodal simulation, and then COVID-19 considerations. Okay, so the first module, getting started, really what we're trying to do here is to uh, impart enough information so that people can understand the purpose and the application of mobility simulation. So we'll look at industry trends, personas. There are some examples of different types of simulations that we'll look at. We'll get to know the interface a little bit. The second module will be about pedestrian simulation. So here we will actually learn how to create a simulation, and we'll create 2 or 3 different simulations. We'll learn about how to build the network, which will include understanding layers, walkways, handles, areas, how to use imagery, and then also simulation criteria such as demands and divisions. Module 3 will cover traffic simulation. So we'll build on what we learnt in the previous session by building a traffic network. And again, we'll look at the basics around building traffic simulations. So we'll look at the different components such as roads, zones, intersections, roundabouts, and also signalling. In the fourth module, um, we'll combine what we learnt in the second and third sections to build a multimodal network. So we'll create a multimodal network in that session, and we'll talk about stands and scheduling services. And then we'll also add on some information about reporting and how to utilize external models to augment the simulation visually. And then the last module, module 5, is regarding COVID-19 considerations. So what we will do is we'll try to make you aware of the features that are available inside mobility simulation that might help us when we're creating networks to plan around COVID-19. So there'll be some general considerations that we'll talk about, and then we'll also talk about how we can implement some of those considerations on a technical basis inside the software by using the various people parameters and spacings and queuing systems. Okay, so getting started, module 1. So why is mobility important at all? Well, it's predicted now that 80% of the global population by 2050 will reside in an urban environment. So that's really showing us that there's going to be a lot of crowded cities, and we need to find a way of all living together and moving around these cities in a safe and efficient manner. Um, so growing prosperity is creating a growing demand for mobility. People want to move around. Um, they have the money to do that. Um, but there's definitely a movement towards uh, multimodal services, which is combining uh, people on foot together with modes of transport such as cars, buses, trains, and even cycles at the moment. And transit-oriented developments are also becoming more relevant. Cities are now being challenged by the increasing problems caused by traffic and transportation in general. Um, Existing urban infrastructure can't support the predicted increase in vehicles um, or that are going to be seen on the road in the future. There's a growing cost of that, the problems that the additional congestion causes. And the WHO estimate that 7 million premature deaths are attributable to air pollution and urban transit, which is obviously a major concern. So as far as who might be interested in this type of technology, um, it boils down really into two main areas. We have crowd simulation and evacuation modeling. So this is generally talking about people moving around generally on foot. So obviously governments are going to be interested in that, but really any type of authority or entity that is running some sort of campus. So we're talking about things like ports, airports, universities, um, commercial businesses, malls. They'll all be interested in how to move people around efficiently um, within their structures. Um, Now, it may or may not be that they have their own technical expertise. Some of them will, some won't. The people that don't, that will then be subcontracted to engineering service providers or specialists in this area. Uh, Traffic systems are usually a larger consideration, so they could be across city or between cities even. So that is generally quite firmly at the door of government. So local authorities will generally be responsible for that, and they'll have their traffic engineers and their transportation analysts that will be using this type of technology. But again, um, local ESPs or specialists will also be involved in that. So why is there interest in mobility at the moment? Well, it's becoming more and more important to cities. Congestion, as I mentioned earlier, is close to unbearable in some cities. I'm sure we've all experienced that. Um, but it's costing as much as 4% of national GDP. And there's a lot of wasted time, wasted fuel, and lots of increased costs of doing business. Cities are also looking for sustainable transportation solutions. A lot of cities are targeted on environmental factors relating to transportation. Um, I've also mentioned the transit-oriented developments, which are starting to crop up around cities. And then we also have the issues around electric vehicles. And then, of course, what is quite current is the COVID-19. So governments have a responsibility to try and contain contain the virus, and so obviously people movement is a big part of that. And also companies need to provide a safe working environment for their workers. Okay, so let's just take a quick look at what mobility simulation involves. Well, it runs inside of InfraWorks, um, and there is a relationship between InfraWorks and mobility simulation. So for people movement, where you want to see people moving around and create a simulation based around individuals, um, you use the mobility simulation tool itself. So the mobility simulation is fired up from within InfraWorks. For traffic simulation, there is a choice. You can use um, the mobility simulation engine running the traffic simulation product inside of InfraWorks itself. For multimodal simulations, you're back inside the mobility simulation window. And then for model augmentation, bringing external models into mobility simulation to augment the model visually, we would use 3ds Max. So as I just mentioned, there's a relationship between InfraWorks and mobility simulation. So InfraWorks provides two main functions. So it drives traffic simulation in InfraWorks mobility simulation. So it works in the background, providing the analytics and the routing of individuals or cars for InfraWorks itself. And also it provides access to the advanced parameters for traffic simulations through the traffic analyst. And then it also serves as a launcher for mobility simulation. So you will have a model open in InfraWorks, and then you will spawn mobility simulation from your InfraWorks window. Okay, so what I want to do now is just move on and have a look at some of the examples that we have of mobility simulation working. So we have a number of built simulations that we can start to examine just to give you some idea of what is possible. So this particular example is of an airport. So we have a fully modeled network for this airport. So we have people arriving in cars, heading through the queuing systems to the manned check-in, and then also the self-service check-in. And then people will go through to the plane, and then when they come back, they go through passport control, and then they'll come out the other end of that, having collect their luggage, and then out to ground transportation. Okay, so this model is available to us, this simulation, and there's a lot more in it than what I'm showing here. Okay, so this next example is about crossings. So this one is really about how all the different modes can work together at a crossing. So you'll see a cyclist on the top right there, and then we've got cars, lorries, people, and the cyclists all working together on this crossing. And then this example is of a traffic system. So that's really expanding what we looked at with the crossing to a city traffic system. So you can see here we have exactly what we had before with the crossing, but with a much larger scale. So we've got people moving around, we've got cars, cyclists, lorries, we've got buses, we've got people moving around, getting on the buses and being moved on that way, and then we have how people travel around different networks as well. And then this one is around ports. So here we have the ferries coming in, people moving out from off the ferries, and then out to ground transportation where they're picked up by the buses, and then are then moved on. This is a rail example. So in this particular one, we have people turning up in their cars, parking, getting out of the car, moving along to the platform, waiting for the scheduled service to arrive. So the train arrives, then everyone gets on the train, or a proportion of them do, and then those people are then moved on through the train to the next stop. This is a supermarket example. So this is very much what we've seen previously, but this is much more concentrated. A lot of cars in a very small space. Lots of car parking going on. People moving around, interacting with the cars. So all the cars and the people are aware of each other. So during the simulation, the people are moving from the car through the car park, avoiding the cars, and the cars are avoiding the people. They go into the supermarket, they do what they've got to do there, then they come back out, get back in their cars, and then drive away. We also have a number of case studies. So this particular one was the Department of Health, Western Australia, BG&E and Multiplex. So the objective of this particular simulation was to analyse proposed parking, public transport and pedestrian access to a major new hospital. And then we also have one that took place at Edinburgh Airport. And this was to compare the time, distance and price of access options to the airport. And this included short and long-term parking, taxis, drop-off and public transportation.
Six weeks from today, a chunk of Riverside Drive will disappear forever, severing one of Perth's busiest roads. It will change the way tens of thousands of us get to and from work and across the city.
32,000 cars use Riverside Drive every day. Soon, those thousands of wheels will be replaced by thousands of litres of water. January 26, Australia Day, is the cut-off. Elizabeth Quay takes shape where Riverside Drive will disappear forever.
Here we have many thousands of pedestrians that cross.
At Main Road's headquarters in East Perth, animated predictions show the morning peak traffic flow around the new inlet.
The journey time may be a minute or a couple of minutes longer. We will be customising the traffic signals to make sure that the flow around there is as good as we can get it.
Main Road says the best alternative to Riverside Drive is the tunnel An extra 12,000 cars a day are expected through it.
So that's the end of Module 1, and we should now move to Module 2.